Dear students, welcoming you in Narayana online digital classes. Today, I am going to explain some of the assignment problems on wave optics, some typical problems from Narayana material I have brought for you. Presenting in front of you, question number 1. See here. Consider the optical system shown in figure. The point source of light S is having wavelength equal to lambda. The light is reaching a screen after reflection from 2 mirrors. They had given you these 2 mirrors for point P to have second maxima. Check here, P just in front of it. So you need 2 coherent sources. One coherent source you will be getting after deflection from first mirror, and second coherent source you will be getting after deflection from second mirror. Okay, no? And you want at point P second maxima. So I have to draw again figure. If I will go here, then D will come here, 3D will come here. So let us take a new page. See here. This distance is D. So, here you will have S1 at a distance D. This distance will be D. So, this is your S1. And here at a distance 3D from here you are getting second one. Now, you want maxima. What is condition for maxima? Path difference between 2 coherent waves emanated from 2 virtual coherent sources must be integral multiple of lambda. For second maxima, it must be equal to 2 lambda. So, you have to calculate path difference between 2 waves. So, this wave will reach here right now. So, path will be S1P. And no other medium is there. So, optic path will be equal to geometric path. Let us calculate how much it is. S1P equal to, this distance they have given you D right now, and this is D. So, this distance will be equal to under root ds squared plus ds squared. If you take one common D, it will become 1 plus ds squared by ds squared power half, binomial expansion d 1 plus ds squared by 2 ds squared. Clear? This is your S1P. Now, go for S2P from point. So, this will be the triangle from here and here. This is the triangle. I want S2P. This distance is D. This is 3 plus 1, 4 and 3, 7. So, S2P will be equal to under root ds squared plus 49 ds squared. Take out D, 1 plus 49 ds squared by ds squared power half. So, if you take this D, it will become 1 plus 49 by 2 ds squared by ds squared. Now, you want path difference. If you take path difference, then S2P minus S1P. So, this D and this D will be cancelled. So, here it will become 5D. 1D will be cancelled now. Minus, here you will have ds squared by ds squared by 1D is cancelled. So, you will have 49 minus 1, 48, 48 by 2, 24, 24 D D. Clear to you? Now, this path difference must be equal to 2 lambda. So, 24, okay, no, ds square by d, this should be 2 lambda. 2 will go 12 times, lambda will become equal to 12 ds square by d. Let us check the answer. Going back, 12 ds square by d, this is the first one only. Your answer is 12 ds square by capital D. Tell me, did you understand it clearly? This is number 1. Now, let us move to next question. Question number 2 now in front of you. A ray of light is as shown in figure. M and N, this and this are two reflected rays. P and Q are transmitted rays. Rays N and Q undergo phase change. N and Q, these two are going phase change of pi. Correct ordering of refractive index. Okay. Let us concentrate on N. If you concentrate on N, it is going for a phase change of pi. You know that phase change will occur when a ray is reflected from a surface backed by denser medium. So it is reflected here, and it is reflected by a surface which is backed by denser medium. It means that from a surface backed by denser medium means N3 is greater than N2. N3 greater than N2. Why? Because phase change of pi is occurring here. This phase change of pi is possible only when a ray goes reflection from a surface backed by denser medium. Now, concentrate for Q, transmitted ray. It is also going a phase change of pi. This ray had come from here, here, here. Already phase change pi has occurred here. Right now, it means that at this place there is no phase change. If there will be phase change, then pi plus pi, 2 pi, there will be no phase change. So phase change has occurred for Q only here, and here phase change has not occurred. It means that N1 is less than N2. It means N2 is greater than N1. Your final answer, N3 greater than N2 greater than N1. Are you understanding this? Always remember, phase will be changed only when reflection occurs from a surface backed by denser medium. On this concept, this problem was created. I hope you have understood clearly. Let us move now to next question, question number 3. You have, undoubtedly reflection is occurring, you have an interface. You see that this is a wavefront. In the adjacent diagram, CP represent a wavefront. Wavefront means this ray and wavefront, you know, angle between these two will be 90 degree. So this angle is certainly 90 degree. This angle is 90 degree, right? They want condition for theta so that there would be constructive interference at point P. Constructive interference will take place when path difference should be equal to n lambda. But here you see reflection is occurring. Condition will be reversed. Now, maxima condition will be 2n plus minus 1 lambda by 2. If minimum also will be taking, it will become lambda by 2. So first and most important factor is to get path difference between these two. So this ray is directly reaching here and this ray is traveling till O and then reaching here. So path difference is CO plus OP. We have to get CO separately and OP separately. For OP, drop here. This angle is theta, this angle is theta. Okay, no? They have given you this distance. So if I will go for cos theta, this will become D. Okay, no? You are going here, cos theta. D by OP. OP will be equal to D by cos theta. So OP is ready for you. And this is also a right angle. In this right angle, this is acute angle. Okay, this is 2 theta. I want OC. So this is, you will be checking here, cos 2 theta. If I go, this will become OP. Right now, this angle is 90 degree. Check here, 90 in front. You are taking for this will be the normal, this will be the base. So cos 2 theta will be your OC by OP. So OC will become OP cos 2 theta. OP is D by cos theta and this is your cos 2 theta. If you are going for path difference, how much path difference you are getting? Your path difference will be OP plus CO. You can take D by cos theta, D by cos theta, you take common. You will have 1 plus cos 2 theta. If you go for 1 plus cos 2 theta, this will become 2 cos theta. So D by cos theta and this is 2 cos square theta. 1 cos theta cancelled. You are getting 2D cos theta. And you want maxima at point P. The minimum should be lambda by 2. So this 2D cos theta, if you equate to n lambda, okay, by 2 and remove single, you will be taking lambda by 2. Condition is 2n plus minus 1 lambda by 2. So you will have cos theta equal to lambda by 4d. Check where you have lambda by 4d. Here, your answer is, if you want maxima at point P, the path difference del x, which is nothing but CO plus OP, okay, now you will start from there. Then you have gone for OP, then you have gone for OC, del x you have calculated and you have equated it to lambda by 2. You are getting cos theta lambda by 4d. I hope you have clearly understood this. Let us move to next question. Now, I am on question number 4. First thing, it's a graph. For graph, and that is also a straight line, you know that for a straight line graph, y equal to mx plus c. First, let us derive the equation. They have given you lambda 60 nanometer. I feel it will not be 60, it will be 600. Okay, no? Because 5000 angstrom, 4000 angstrom, that is usual value of lambda. So if you will be going for nanometer, it will be 500, 600, 600 nanometer. A thin, transparent plastic sheet of thickness T is placed in front of one of these slates. Number of fringes shifting on the screen is plotted. So path difference, how much is there? mu minus 1 into t, this is n into lambda. You have taken n on y-axis. So, n will be equal to mu t minus t by lambda y mx plus c. On x-axis, you have taken not m, it will be mu. On x-axis, you have taken mu. So, slope is how much? Slope is t by lambda. Your slope is t by lambda. We have to get the slope from this straight line. Slope means tan theta. This angle is theta. So, slope m, this is your tan theta. How much tan theta will be? Perpendicular by base. This is 40. 2 minus 1 is 1. This is 40. Understanding now? It means your t by lambda is 40. T will be equal to 40 times lambda, 600. 600 means 6, 10 to the power minus 7 meter. Your answers are in micrometer or millimeter. Let us convert into micrometer. 10 to the power minus 6, 1 0 will go. 24 micrometer. Check here. Answer is 24 micrometer. A beautiful problem. They have drawn a graph in between refractive index of plastic sheet or thin film, which is introduced in the path of one of the interfering beam in interference YDSE, and how many fringes are shifting, and they had taken on y-axis. And from that, they had asked you thickness of the film. Okay? You have got, check here, from the slope of the graph, you have got the value of t by lambda. I hope you have clearly understood the solution. Let us move now to next problem. I'm on number 5 now. A monochromatic beam of light falls on YDSE at some angle as shown in figure. Okay, these are the rays. You take one ray here also, no problem. Okay, no. The ray is falling like this. A thin sheet of glass is introduced in front of the lower slit. So, this will be S2 and you are introducing this one here actually. Okay, no? The central bright fringe will be obtained. Central bright fringe you are obtaining at any point where optic path of coherent waves emanated from S1 and S2 will be equal. Am I right? The central bright fringe for that will be going behind optic path. Let us go for optic path. This ray, if I drop a normal here, and if this distance they have given or not, if this distance is d, then this will have value d sine theta. If this is theta, this angle will be theta. It means that the wave which is emanated from S1 and reaching to point O is traveling additional distance d sine theta. But if you take the wave this side, which is emanated from S2, it is passing through your transparent film, whatever they have kept there, glass they have kept. When it is passing through thickness T, then it is traveling additional path mu minus 1 into T. Means both have additional path. This upper one have additional path d sine theta, and this one have additional path mu minus 1 into t. I have told you, for central maxima, the path traveled by light, by coherent wave emanated from S1 and S2, these two should be equal. This one is traveling additional path d sine theta, and this one is traveling additional path mu minus 1 into t. If these two will be equal, at O you are getting central maxima. If this will be greater, central fringe will shift upward. If this will be greater, central fringe will shift downward. Right now. So you have to see if these two equal, you will get at O. If d sine theta is greater than mu minus 1 into t, it will go up above O. If d sine theta will be less than mu minus 1 into t, it will go downward. Tell me, did you understand clearly? Check the answer. At O, above O, below O, all are correct answer depending on this. So answer will be your D. Anywhere depending upon angle theta. Anywhere depending on angle theta, thickness of plate, refractive index mu, it will depend upon all the three factors. You can check here, it will depend upon d, theta, mu, t, all four. So answer will be D. Tell me, did you understand this clearly? I am moving now to next question, question number 6. Check here, M1 and M2 are plane mirrors and kept parallel to each other at point O. There will be a maxima for wavelength lambda. Light from monochromatic source of wavelength lambda is not reaching directly, means after reflection it is reaching. Again they are asking you lambda. You have to go for coherent sources, right now. So this is d by 2. This side S1 you will be getting at a distance d by 2 from here. This distance is d. You will get S2 here at a distance d. Clear? No? Again you will have to check. They want light from a monochromatic source reaching here. They want lambda value, and there will be a maxima for wavelength lambda. Do you want maxima there? You go for the path difference. From here, this is S1O, this one is S2O, right? This distance they have given you d, this is d by 2, this is d. So I will go for S1O first. This will be equal to under root ds square plus ds square. Here no, this is d, d by 2, you take this d by 2d, you take out d, 1 plus ds square by ds square power half. How much you are getting? d, 1 plus ds square by 2 ds square. You have used binomial expansion. You have neglected higher powers of ds square by ds square. If you go here, then this distance is 2d. So S2O ds square plus 4 ds square. Again you take out d. Here it will be 1 plus 4 ds square by ds square power half. So this is equal to d1 plus 2 ds square by ds square. Take path difference. If we take path difference, this and this, what you are getting? 2 ds square by d. And here, if you are going for, then you will have minus ds square by 2d. How much you are getting? 2d, right now? And this is 4ds square minus ds square, 3ds square. Clear to you? This you will have to get equal to lambda. 3ds square by 2d must be equal to lambda. Check now. Path difference lambda should be equal to 3ds square by 2d, and answer is here. If you want maxima at O for wavelength lambda, lambda should be equal to 3ds square by 2d, which is nothing but path difference between two virtual coherent waves, means two coherent waves emanated from two virtual coherent sources S1 and S2. You will be thinking, sir, you have considered reflection, why you have not taken phase change? Yes, here there is phase change of pi, here there is phase change of pi. Phase changes are there, but both are equal now, pi, they are cancelling each other. So answer here is number 2. I move now to next question, question number 7. You have two monochromatic and coherent sources S1 and S2. The initial phase difference is 0. They are asking you correct statement. A small problem. In bracket S they have given you. It means that even one answer may be right or more than one may be right. If this type of question multiple will be there, no, you have to analyze each and every alternate. So it is not actually one question, it is equivalent to 4 questions. You have to check each and every alternate. So I am starting from number 1. If 7 lambda by 2, O will be minima. We know when path difference between two coherent waves will be odd integral multiple of lambda by 2, we are getting minima. They have given you 7 lambda by 2. It is in the form del x 2n plus minus 1 lambda by 2. That O, you will be getting minima. It means number 1 is, beta, number 1 is 100% correct. Now go for second alternate. If D is lambda, only one maxima can be observed on this screen. You have to get below lambda odd integral multiple. Lambda already n is 1. How will you go below that? You will have only one maxima which will correspond to second one. You will tell, sir, 0 you take. If I will take a 0, then S1 and S2 will coincide na? And above lambda you will not take. So you have only one single lambda which will correspond to only one maxima. It means that alternate 2 is also 100% right. Okay. Now let us go for number 3. If D equal to 4.8 lambda, the total 10 minima would be obtained on the screen. We have to analyze. You have to start from plus minus lambda by 2. Okay. So first I am going for plus minus lambda by 2. 2 minima. Okay. Next I will go for plus minus 3 lambda by 2. Again 2 minima. I will go next for plus minus 5 lambda by 2. Again 2 minima. Next I will go plus minus 7 lambda by 2. It is still 3.5. 7 by 2 is 3.5, no. Again 2 minima. Next I will go plus minus 9 lambda by 2. 2 minima. 4.5, they have given you 4.8 lambda. It means that if I am going for 11 lambda by 2, it will become 5.5 lambda. They had given you only 4.8 lambda. So you'll have to stop here only. Now count 2, 4, 6, 8, 10. How many minima you are getting? 10 minima? It means that number 3 is also 100% right. Good. Fourth one, you are capable to see now? Fourth one, if it is 5 lambda by 2, the intensity at O would be minimum. Better than this question would be, if they will ask if 5 lambda by 2, how many minimas you are going to get? Okay, if it is 5 lambda by 2, you will get 5. Little house at. The in front here 5 lambda by 2, 1. Plus minus 3 lambda by 2, 2. Plus minus lambda by 2, 2. Total how many? 5. If I have to create, I will make it. If 5 lambda by 2, number of minimas on the screen is 5. But they are asking you intensity at O. 5 lambda by 2 is also just like number 1, 7 lambda by 2. Here it was minima. Here also it will be minima. Clear? No? Because it is odd integral multiple of lambda by 2. Fourth is also correct answer. So 1, 2, 3, 4, all are correct for you. Did you understand this? Clear now? Now, I am moving to next question, question number 8. See here, again it is interference due to thin film. Here you will only check how much phase change is occurring. In this case, when you take reflection, you have to consider the phase change. Phase change, whenever a ray is reflected from a surface backed by denser medium will occur, there will be phase change of pi, which is corresponding to lambda by 2. Now, let us see the problem. A thin film of a specific material can be used to decrease intensity of reflected light. There is destructive interference of waves reflected from upper and lower surfaces of the film. These films are called non-reflecting or anti-reflection coating. Process of coating the lens of surface with non-reflecting film is called blooming. You know it as shown in figure. Refractive index of coating is N1 and the glass is N2, N1 is less than N2. If a light of wavelength lambda is incident normally, very nice, normally means I is 0, R 0. You know path difference is 2 mu t cos R. If you consider here, this is traveling additional distance. If I name it A, B, C and drop normal here D, the real path difference will be AB plus BC minus AD. Clear to you? So this will be equal to 2 mu t cos R. So here mu is N1. 2 N1 t cos R. R0 R0 cos 0 is 1. It will become 2 N1 t.
Always.
You want destructive interference, right? No. For destructive interference, see here, this is air, this is film. It means it has additional path difference. Okay, no? That one is lambda by 2. And here also it is lambda by 2 if you consider. They are asking you if a light of wavelength lambda is incident normally and the thickness of film is T, the optic path difference between the waves reflected from upper and lower surface of the film. So this 2n1t, you take it as m lambda plus lambda by 2. This will become 2n1t minus lambda by 2. Okay. So optic path difference between these two will be equal to 2n1t minus lambda by 2. Clear? So answer will be number 2, 2n1t minus lambda by 2. Or if you want to calculate, very simple, either you use the formula 2 mu t cos r, okay, and equate to 2n plus minus 1 lambda by 2, okay. Or if you really want to calculate for the theory, you take it I, this will be R, drop normal here, it will be R, it will be R, then your path difference will be AB plus BC. This is additional path which this ray has traveled. And this ray in comparison to this has traveled additional path AD. So in between these two rays, if you want to compute path difference, you have to take AB plus BC minus AD. Is it clear to you? I hope you understood it. So answer is number 2 for question number 8. Now let us move to next question. Question number 9 you have here. In a modified YD assay, the region between the screen and slit is immersed in a liquid. Oh, here refractive index is varying. Until it reaches a steady value, we are not at all interested in this 5/4 thickness they have given you. Refractive index of 3/2 they have given you of glass. Find the time when central maxima is at 0.2. Because you have introduced this, central maxima will shift downward. And because mu is varying of this medium, so what will happen? Central maxima will be going on, moving up. They are asking you after how much time from t equal to 0. Okay, after how much time central maxima will reach to 0.0. To know central maxima, we will have to go for the path difference. Okay, no? For central maxima, path difference should be 0, means path traveled by this light and this light should be equal. Okay, no? I have to take path difference 0. So del x, first I am going for del x. How much for this? If I treat this distance as x, so this will be in medium mu1 t x you have taken, so x minus t, okay, this is x minus t, this is the distance optic path traveled by light here, plus mu glass into t, this minus mu1x, mu1x, x cancelled, how much you are getting? Mu z minus mu1, this is mu1 t na, into t. Check this, we are getting mu z minus mu1 into t. And you want x, okay, no? So this will be equal to x d by d. So your x will be equal to mu z minus mu1 t d by d. Concentrate on mu g minus mu1. Mu g is constant. Okay, one thing more will be there here. Mu g how much? Okay, no? So mu z is 3/2. Mu1 5/2. Okay, no? Minus t by 4. And because the thickness you are considering, this distance x, here this x is not x but it is mu1 x. So this x here additional mu1 will come, because it is mu1 x d by d, because you are taking not in air but you are taking in a medium, right? So x will be equal to mu g minus mu1 td by mu1 d. Other distances t, d and d, we are not much interested. We are interested in mu g minus mu1 by mu1. The first mu g 3 by 2 minus mu1 minus 5 by 2 minus 5 by minus t by 4, so it will become plus td by mu1 5 by 2 minus t by 4. So how much you are getting this one? td, this d constant, you are getting here 2. Check it here. 3 by 2 minus 5 by 2 is 1, na? 3 minus 5 minus 2 by 2 is minus 1. So it is t by 4 minus 1 by, if you will go for here, it will be 10 minus t by 4, and this constant, let it be here. Okay? How much you are getting now? Your x equal to t minus 4, 4 cancelled, by 10 minus t, and this td by d. This x should be 0 if you want central maxima. For central maxima, x should be 0. This can't be 0. T cannot be 0, capital D cannot be 0, small d cannot be 0. If I take this t 0, anything by 0 will become infinite. So guaranteed this t must be equal to 4. Numerator should be 0, then only x will become 0. It means that t minus 4 should be equal to 0. T minus 4 will be equal to 0. It means that t must be equal to 4 seconds. Understanding me now? Means after 4 seconds, central maxima will be reaching to point O and it will not be remain there. As time will be passing, it will be going on passing. So answer here is number 2. T will be equal to 4 seconds. Understood now? Clearly? This one was number 9 now. I'm moving to next question you have in front of you. In a modified YD assay, source S is kept in front of slit S1. Source S is kept in front of S1 means this point is S1, not this. Okay? Find the phase difference at point O that is equidistant from slit S1, S2 and a point P that is in front of slit S1 in the following situations. Answer is only one. They are asking you phase difference by seeing all the alternate. If they will take at O, this will become equidistant. S1O will become S2O. If you will take the first point phase difference, then directly I can say it is S S2 minus S S1. Second term will not come. It means that whatever alternate they had given you, it is only for phase difference at point P. Right now, the first I want that, so it will become, this one is traveling how much difference? Path difference you go. S S2 minus S S1. This is before the two slits. And after the slits, it will be, after the slits, S2P minus S1P. This one so many times you have found. But anyhow, let us calculate this. S S2. This distance you have taken as d. The S2 if you are taking, this will be this square plus this square under root. S2 is under root d square plus x naught square minus S1. Directly they have given you x naught. So this path is this. Now you want S2p minus S1p. Right now they should give this distance is d. So this distance is d by 2. Right? And this distance is capital D. You can easily get, because here they have taken a liquid. This entire medium is filled with a liquid. This distance is d by 2. S2p when you take, it will become mu times S2p. So it will be, I'm writing here, this path S2p minus S1p, it will become mu times, because both rays are traveling in that. With geometric path difference S2p minus S1p, automatically it is d square by 2d, because this distance is d by 2. Clear? So this will become mu d square by 2d. Clear? The net path difference will be this plus mu d square by 2d. The path difference between two waves which are emanated from S1 and S2 and reaching at P is this. Phase difference is how much? 2 pi by lambda into path difference, no? So entire this you consider and multiply it by 2 pi by lambda. Your answer will be ready. Check. Under root d square plus x naught square. Okay, no. Plus x naught impossible. Here it should be minus x naught. It is ruled out. It is ruled out. It is plus x square. This is ruled out. Answer will be number 2. 2 pi by lambda under root d square plus x naught square minus x naught plus mu d square by 2d. Tell me, did you understand it clearly? All the problems, whatever I have brought, I hope you have clearly understood. Okay? Again, with a new assignment, I'll be coming in front of you. I'm hoping that each and every problem you have clearly understood. Still, if you would have doubt, you can contact me. I'll be very happy to give answer to your any problem or any question. For now, thank you to all of you.